Start over? Yeah, Clora's wife's interrupting stuff there.
It's fine. I can't believe you're actually taking a video.
Well, I won't remember it if I don't video it. I mean, I want to make sure I have all the wording right. Just do it real quick.
You serious?
Come on.
Okay, so I can't remember how to use.
I won't argue with you on that spelling.
Euclidean space.
Okay.
This is what you use if you're trying to analyze the distance. This all, for one, is Euclidean space. I'm just going to put it as a circle. That's the space on the matrix or the plot that you want to as your scope. Let's say this is just a scope or domain. Domain means those are in common, or what you're analyzing. Often you want to find what's in common so that you can have it in a closer space. You use a Euclidean distance formula. The distance formula in the Euclidean space as the method equals Euclidean. Then you give it, let's say 1, 2, 3, 1, 2, 3, negative 1, negative 2, negative 3, 1, 2, 3. Okay, so what is a parabola that we're speaking of?
Well, we told Rochelle that was the bell shape.
Yes.
Okay.
You can see
She
here.
didn't know. She didn't know nothing about parabola.
You can see here that the mean is obvious. 2 is the mean. You can denote it as that. I think that's the mean.
It looks
that's
close
how you
enough for
denote
me.
the mean.
That's close enough for me.
This represents the mean.
Sure. Well, that makes it clear right there. Okay.
So if you somehow find that there's a cluster, and that cluster there is normally distributed. If you find that it's normally distributed, you would have this curve. Because they're leaving at similar standard deviation.
And in order. Okay.
Yep.
Let's go. Let's finish this up.
So I can't believe you're still.
I want to be able to watch this quickly.
So, like, let's say this cluster equals. Let's say somehow you found what the cluster and what was the dimensions in common. You find out that was equal to Spirit Airlines. And their stock history from time 1 to time 5. And you're trying this, and this right here represents that time and space. So I'm just going to show the parabola. So that little parabola that you cared about in that plot. Let's just say we only wanted that section of the graph. We had other sections, but we only wanted that section because it was mostly positive. It was all positive, in fact. All of it was going in a positive direction. And that was the parabola we had. Let's say the mean was 2. That means if the mean was 2, that cluster within time 1 to time 5, their mean was 2. And you can say maybe it was within 2 standard deviations. I can't remember the formula to compute the standard deviation. It's something like
I'm sure it's
mean
simple.
minus x.
It's not.
over-
How about that standard deviation formula, Rochelle? You got that off the top of your head?
For the parabola,
No. Yeah. Well, actually, yeah.
22.
No. Quit playing, joking
So
around.
I think it's the mean, I believe, because if you think about it, the mean minus the variable you're interested in. Let's say this is airline, the airline you're interested in. And that's x, the stock from that airline. So you're taking what's normal, let's say this normal was 2, but on that time t1, or actually time t2, actually this would be 1, 2, time t1, time t2, time t3, time t4, time t5. Let's say that's what happened in those times. If you were trying to find the mean
Yeah.
and the standard deviation, let's say that one,
He
5.
He calls it meme. I call it sweet spot.
if you're trying to take 5 as the mean, 5 minus 2 divided by
3.
5, which equals
Oh.
3/5, is that's how far in proportion to that you are from the mean. Let's say if it was that, you should be able to take...
Oh, so I have to calculate each one of these down here by 5?
What?
Yeah.
That means
Well, that one.
2
3.
standard deviations.
Oh, 2 standard
that?
deviations. Sounds good.
2 standard deviations. Because these are like the standard deviation 3 was over all these. Standard deviation 3 was like way out here, and we're going to call those outliers because those don't represent that cluster. Or maybe this was within years, but on like a specific day, it was like 10, but it's normally 2. That's an outlier. Something really happened. That equals 5 standard deviations, and we don't care about 5 standard deviations. We just care about what's within the 2 standard, because that's normal. That's what we're comfortable with. That's what we can predict in that time period.
Sounds good.
But if it's something that's an outlier, don't worry about it. It's not part of what's common within that time. That's an example. But you can also have what's known as covariance, where you want to balance the direction that the input is going, or the output from those variables.
All right, we'll say that for another video.